So today we will talk about exceptions and exception handling, which is basically how to deal with user input errors if syntactically the problem is well defined but is not defined from the semantical point of view. For instance, we know that in mathematics you can divide two integers unless one of the integers is 0. So that is not defined in mathematics, not equal with anything. Okay? So we will actually try to implement this problem using exceptions and exception handling. So exception handling is about capturing errors while you are executing the program without showing the user that there was an error in the program. So we actually want to catch this exception, this error, exception of the input, user input, into a program. So exceptions or handling exceptions is basically catching runtime errors when the program terminates abnormally, and we want to handle this termination, this runtime error, in such a way that is nice and prettified that the user can either continue to run the program or terminate the program but without crashing. Okay? For instance, division with 0. The simplest program that you can write for division by 0 is that you import a scanner object and then you ask the user, prompt the user to enter two integers, number 1 and number 2. This program works fine for most of the inputs. It works fine as long as number 2 is different than 0. It does the division, returns an integer division. However, if the user enters for the number 2 0, the program will crash. Basically, you will see a red output saying that there is an error in line 10, the division line, and then the program will just exit. We want to capture that exception, that exceptional case of a division, and basically to finish the program gracefully. We want to end the program without generating a red message, and the user that actually doesn't know programming will see that red message, which doesn't mean anything to him. He does not see the original source of the program, and he doesn't want to fix it. You should be the one that fixes the program. So one way to fix this program would be to put an if-then-else statement. If the number is different than 0, then we will execute the division. Otherwise, we print out that the divisor cannot be 0. The problem is that in this method, we actually assume that the current method is the one that does the division. However, the division method, the divide method, can be implemented by somebody else. So now you basically, the return of that method will be an integer unless there is a division by 0. So for the same program, if the error is generated from an inner method, you basically have to catch that exception. That is an exceptional case, a runtime error. Now, it's easy to handle this kind of an exception if it's in the same method. So the division operation may trigger an exception. If the exception is triggered, then we print out that this is an exception, it was a division by 0. Otherwise, we do not do that. Okay? So we saw this before, try catch block, when we talked about division by 0, when we talked about clonable interface. The clone method is not implemented for all the classes. So if you call it for a class that does not implement the clonable interface, it will tell you that we cannot clone this object. And the way to do it is you get a runtime error, not a execution, not a static error. Yes, please. Okay. So the exception is also an object. It's a hierarchy of exceptions. You have the throwable superclass, exceptions, and errors. So what exactly we are catching we are catching the address of an object of the type exception. So here, once you get an exceptional case, a runtime error, the program will try to find the first catch block that catches that exception. So it basically stops the execution, doesn't execute anything else until it finds a catch statement for the type of exception that was triggered, or a supertype of that exception, because every subtype is also an instance of the supertype. Does that answer your question? Or what was your question? That was your question. Oh. Sorry, I didn't hear you. I see. So this actually also, your question is that if you enter letters instead of numbers, that exception is not, that try and catch block is not treated here. So we will not catch that exception because it looks for catch blocks in the same block with this instruction. And it will not find it because the catch block is under the try block. So for that exception to be caught, you have to put this try statement before you read the integer. But that is another type of an exception. That is an input exception. Number is not in the right format. Any questions? Okay. And that we will see how to do that, because in fact what you asked is part of the quiz today. We are reading two numbers and we try to implement a calculator, and you can see that I have the parseIn method within a try, and then I have a catch block that catches that format exception. But before you start implementing the program for the quiz today, let's talk about exceptions now, so you know what we are talking about. So now, if your exception is generated inside an inner method, you have to define that that inner method also throws an exception. And now your call to the inner method is within a try-catch block. So it's similar to what we did before, only that now we have to define that the method does not only return integers in the case of the inputs being correct, but may also throw exceptions. Yes, please. Yes, arithmetic exception is a superclass of division by zero exception. So it's predefined. Okay. But it's in this hierarchy that we will see in a couple of minutes. Here is a hierarchy of exceptions. It doesn't list all the types of exceptions. There are 100 different types. So basically what we can do for a method is to throw an exception and catch the exception in a caller that knows how to handle that exception. So methods may return beside of the return type, like in the case of quotient, it does the division of number 1 with number 2. It returns an integer. However, in the case that number 2 is equal with 0, it actually throws an exception. So it stops the execution of that method, goes on the call in the caller class, and tries to find a handler for that type of exception. So in this case, we explicitly throw an arithmetic exception. Divisor cannot be 0, and that exception is called in the catch block. Arithmetic exception is a subclass of exception, and we will have that the exception was that an integer cannot be divided by 0. Jager.
Random question. In the catch exception, why is the block for system out there? Why do you have two strings? Why not just one?
Because I couldn't fit it in one line.
Okay.
Any questions? Yes, Martin.
So basically this is catching a runtime error.
This is catching a runtime error, and the runtime error is worse than a exception, because the exception, we can handle it and we can print pretty messages. We don't have to print the error stack to a user that doesn't have access to the code and doesn't know what to do with that error. Okay? So what the exceptions help us? It basically helps us for throwing beside the return of the message also exceptions to the callers. And without this capability, the method will just terminate the program or it will crash. Okay? So exceptions are a way to handle runtime errors, which we can predict that there may be a runtime error. For instance, when you try to open a file and that file may or may not exist on the disk, if it doesn't exist on the disk because it was not created by the user in the operating system, we will get an exception, a runtime exception. We cannot create a file for this path in the file system. And a way to handle that exception is to catch that exception and just tell the user, instead of giving a runtime error, that you have to provide a file, or you have to provide a link to that file, a path to that file. Now, here we are actually using an exception in order to tell the user that he did not enter an integer. So this is addressing your question. Like, we know that we can create a scanner for the standard input, the command line input, but we want to ask the user to enter an integer. The user may enter other things than integers, for instance, the string hello. In that case, the next int method throws a number format exception or input mismatch exception. The fact that the expecting input is not of the type int. In that case, we stop the execution at this line without executing the print or the assignment statement, and if the exception was detected, we continue with the statements in the catch block. In the catch block, we inform the user that the input was in an incorrect format, an integer was required, and then wait for the user to press enter to go to the next step. But since we enclose this whole try-catch statement into a do-while loop, basically since the continue statement is still true, we are asking the user to enter a new integer. And this will happen as long as the user does not enter an integer. So every time the user enters something else that is an integer, it prompts the user that he has to try again and asks for a new integer. Once the user enters a correct integer, a string that represents an integer, we display the result, which is the number that was entered, and we assign false to the variable continue input, which will also exit the do-while loop, because the condition of the do-while loop becomes false, and it continues the execution. In this case, terminates the program. Any questions? Yes, please.
Would that still work if you plot a regular exception?
The only instruction that we have in the try block that can throw an exception is the next int method. So that's the only instruction that generates an exception, because this is just an assignment or a variable that is Boolean. This is a print statement with a concatenation of a string with a number. So the only instruction that we have there is next int. But if you generate a different type of an exception, it will basically not work, because the input mismatch exception is just a subclass of exceptions. Exactly. So if you have multiple types of exceptions, you will write multiple catch blocks for each type of the exceptions. Okay? Any questions? So you can have multiple catch blocks for one try. And another statement that you may have is finally. So after you tried all the possibility of the catch blocks, you have a finally, which is executed no matter if there was an exception or there was no exception. It's used for closing up streams that you are opening in the try block, cleaning up the memory usually. So exceptions are organized under the class object as a hierarchy. You have the throwable class, which basically defines that everything that is in this class of runtime errors, and it's classified into two hierarchies, exceptions and errors. Errors are virtual machine errors, like for instance linkage errors, that you are trying to access a library and is of the wrong version, so it does not contain some classes that you require. You will get an error, and you cannot do much in that case. Basically the program will just crash because it's a Java virtual machine error. And the exception class, which are these runtime exceptions that you can catch, and they can be either runtime exceptions, which are exceptions which are unchecked exceptions. You have a null pointer, you have an index out of bounds, a character of an array that it's out of bounds again, arithmetic exceptions, and so on. And you have other exceptions like input-output exceptions, are when you try to open for reading a file that doesn't exist on the disk. Class not found exception is the exception that you get if you try to run a class that doesn't exist, the class file for it, and so on. So basically you have the different classification of exceptions. System errors are thrown by the Java virtual machine, and there is not much that you can do about that. They are very rare exceptions, only when you are using the old versions of libraries, or there is a problem in your Java virtual machine. There is not much you can do in that case. So the program will just terminate. You can catch the exception and terminate a little bit graceful. Tell the user that we save the state, save what you can, and then finish. We have exceptions, which are errors generated by your program. And these exceptions you have to catch. You don't want your program to crash. Okay? And when you catch these type of exceptions, you should handle the exception and print a nice message. Why did you crash? And how can the user correct the program? Within the class exception, we have a set of runtime exceptions. These are called unchecked exceptions because Java does not require that you are putting instructions that may cause this kind of an exception within a try-catch block. Like for instance, every time you try to access the data fields of an object, it can be generated a null pointer exception if your object is never initialized. But you don't have to put that in a try-catch block, because these are errors that are caused by programming errors. So once you deliver the program, it's supposed to be free of any kind of errors. Okay? So these do not need to be caught. But you still have these errors in your program. You can still have them. Index out of bound exceptions is when you are using an index that is not within the bounds of the array, 0 to the length of the array minus 1. Is the same type of exception that you get if you try to index an element, a character in a string, out of the bounds between 0 and the index of length of the string minus 1. Illegal argument exception when you try to call a method with wrong type of arguments, and so on. Beside those, the error class and every single subclass of runtime exceptions are called unchecked exceptions. All the other exceptions, so all the other exceptions that are not in this block, in the yellow portion, are checked exceptions. The difference between these two classes of exceptions is that for unchecked exceptions, you do not have to put them within try-catch blocks, because Java does not mandate you to catch unchecked exceptions. And the reason for that is that Java doesn't want you to clutter your program with too many try-catch blocks. But all the other exceptions, class not found exception, IO exception, clonable not supported exception, and so on, are called checked exceptions. That means that Java requires that you, when you clone an object, for instance, you have to put either that you are throwing the exception from the current method, or you enclose the method that can trigger that kind of an exception within a try-catch block. So there are two classes of exceptions: checked, which must be put within a try-catch block, and unchecked, which you do not have to put them within try-catch blocks. Any questions? So unchecked exceptions, they reflect programming errors, and you basically have to fix those errors in the program. You detect those when you try to run your program for the first times. For instance, the fact that you have a null pointer exception, when you try to access a field for a reference variable and that reference variable was never initialized. Index out of bounds exception, when you try to access an array at a given index and that index is not between 0 and the length of the array minus 1, and so on. These are logical errors and you basically have to correct them. You don't have to put try-catch blocks. Now, for all the exceptions, all the other exceptions, the checked exceptions, you have either to put them within a try-catch block, or your class that generates the exception, throws the new exception, should throw, your method that generates the exception should throw that exception. So for checked exceptions, you have to catch the exception, declare the exception in the method definition, and throw the exception if you are throwing an explicit exception. Okay? So exceptions, again, they are runtime errors, and they can be automatically generated by the virtual machine when there is a runtime error, like for instance division by 0, but you can also throw them explicitly with the throw instruction. In all cases, if you have an exception that was thrown explicitly or implicitly by the Java virtual machine, your method might throw that exception, and any call to a method that throws exceptions must be put within try-catch blocks. Martin.
So if you throw an exception but don't have the structure set up to catch one, it basically crashes your program, right?
If you throw an exception and you don't have the structure to catch the exception in the caller, in fact you have a static error, you have a compiler error. Java will inform you that the method 2 that you are invoking throws an exception, but you did not put it within a try-catch block. Okay? So it's automatically checked at compile time. So you will not be able to run the program. So now we will learn how to declare the exception, throw the exception, and catch the exception. So first of all, methods that state that you basically throw some type of exceptions can state in the method definition that the method myMethod also throws an input-output exception. This is called the declaration of the exception. If you throw multiple types of exceptions, like for instance IO exception or other type of exceptions, you can separate them with commas. Now, you can explicitly throw an exception. So the Java virtual machine will throw exceptions when it will have runtime errors, like for instance, the file was not found or there was a division by 0, but you can do it explicitly. You can check if the condition is true, then you throw an exception. Now, every exception is actually an object. So exceptions are useful, but they are kind of heavy. You are creating an object on the stack of a reference type. It carries all the data fields that are for that exception class. It also carries the methods which can be called for that object. So exceptions are useful, but they are kind of expensive. Time to create the object, the space to create the object on the heap. So in order to throw an exception, you can create an exception variable that is an instance of the new type of the exception and then throw that exception variable, or you can create an anonymous exception an object and just throw it. The program will stop the execution at this line and try to find a catch block to catch that type of an exception. So now, putting together the declaration with the throwing of the exception, we can write a method setRadius for a circle class that when it gets an argument that is not greater than or equal with 0, it throws an illegal argument exception, that the radius cannot be negative. So now we have the fact that the setRadius method sets the radius to a new radius, and in the cases that it has a runtime error, it throws an illegal argument exception. Martin.
Is it possible to create your own exception?
Yes. So Martin is asking if we can create our own user-defined exceptions. You can create any subclass of the exception class that we have here and define what are the fields of our new exception class. Like for instance, in the quiz we will have that a hexadecimal digit is not correct. So we will create our own class of hexadecimal format exception and then use it, throw it from a method. Now, how do we write try-catch statements? We can try to execute statements that may throw exceptions, and then we can catch the type of the exception that was thrown by those statements. We can catch exceptions of the type 1, exceptions of the type 2, exceptions of the type n, and so on. And in each case, we can write what statements will be executed by the handler of that exception. So when an exception is generated, the program stops the execution of the rest of the statements and finds the first catch block that catches that exception. Any questions?
How much processor time does it actually eat up trying to look for the exception?
Basically, what this do is it checks if the exception that was thrown is an instance of the type that was given here. So it's one comparison, one execution clock time. One comparison between the type of the exception and the type that is given here in this instance of statement.
So it's kind of, when you...
One clock time.
Right, so
Like
it's very quick.
very quick.
Okay, relatively.
Yes. Now, it doesn't look only at the current level for the try-catch block. If it doesn't have the type of the exception that was triggered, it looks into the stack, it rolls the stack to find the next method, the method that the caller for the current method. So in this example, we have a main method that tries to execute a method 1. Tries to execute it in a try-catch block. Method 1 calls method 2 within a try-catch block. Method 2 calls method 3, which actually throws an exception. Now the question is, which of the catch blocks will be considered for this exception of the method 3? We will try to match the exception type of the exception that was triggered by method 3 with the catch block that we have here in the method 2. If it's not the type of the exception that was triggered, it continues, it rolls down the stack to find another catch block. So it's like writing try and within the statement another try with a catch block. So now if the exception is of the type E1, it will be handled by this catch block and then continue the execution. If the exception is of the type E2, it executes what is in this block and continues the execution. So the order to find the exceptions is from the point where the exception was triggered, roll back all the catch blocks, so finish all the methods until you find the catch that catches that exception. Execute the catch block and then continue with the rest of the statements that you have on the stack. Yes, Tara? So, all the exceptions are exceptions of the subclass exception. Okay? So now we have multiple subtypes of exceptions. Let's E2, E1, and so on. These are all classes. The method M3 triggers an exception of the type E1. So if my catch here catches only exception of the type E3, it basically tries to find the next exception that E1 is of the type of. So it tries to find the first catch block that catches the type of the exception that was generated by method 3. Any questions? Okay. So now for checked exceptions, since they are Java requires, since they are not programming errors, they are basically interface errors. There is not a file on the disk, or the user enters the wrong value, and so on. Java forces you to deal with checked exceptions. That means that if the method P2 triggers a checked exception, like an input-output exception, then any caller of the method P2 must either throw the exception or enclose it within a try-catch block. And the rule is simple. If the current method knows how to handle the exception, what to output to the user in the case of that exception, if it knows how to do it, then you should put it in a try-catch block. If you don't know how to handle the exception, you throw it to the parent, to the caller of the method P1. So one of the two methods. Handle the exception yourself basically means ask for the user for a new input, or inform the user that the file cannot be opened, and then exit the method. Or throw the exception and then the caller must do that. You are right. So if you have the try-catch block of the type of the exception that is generated by P2, you don't have to put a throw IO exception because you are not throwing that exception any further. You can do that. One way to handle the exception is that in the catch block, you are throwing the exception again. So I code the exception, I handled part of it, and since I still want to inform the caller that there was an exception, throw it again. It's calling rethrowing the exceptions. So it's partially handle the exception and then throw it again. Okay? So let's see an example. I have the circle with exception class, which it's a circle, has the dynamic property radius, the number of objects is equal with 0, a static property, two constructors, the default constructor which calls the constructor for circle with exception with a double 1.0, a circle with exception constructor that takes a double, a new radius, and throws an illegal argument exception, calls the method setRadius. SetRadius sets the radius to a new radius. If the new radius is greater than or equal with 0, we set the data field radius to the new radius. Otherwise, we throw an illegal argument exception that the radius cannot be negative. So you can see that the set method throws an illegal argument exception. Therefore, the circle method, the constructor, should either use a try-catch block here or continue throwing that exception. Okay? So now, once we create a circle with the given radius, if that succeeded, we increment the number of objects. Okay? So in my main method, I can create 3 circles. circle 1, circle 2, and circle 3. I try to create the 3 circles. However, when I try to create the second circle, the circle with exception method will call the method setRadius, which generates, since the radius is -5, generates an illegal argument exception. That is thrown from the setRadius method to the constructor method. Since that has an exception, it throws it to the main method, which catches that exception and prints the exception. So once that exception was generated in the constructor of the set method of the second object, it will never get to create the third object because an exception was triggered. So the number of objects that were created is the number of objects that were created before that exception was triggered. So only for the first object we incremented the number of objects with 1. The other 2 instructions never succeeded. So how many objects did we create? What is the output of this line? Number of objects created is equal with 1. Excellent. Because at the second object there was an exception triggered, we stopped the execution and we just executed the catch block. So here we had an example of declaring the exception, throwing the exception, and catching the exception. Yes, please.
We had a third object we created with a positive radius. How do we have it so it creates the third object?
You cannot. So basically what you can is to put 3 catch blocks, 3 try catch blocks. You basically can take this program and the first instruction creates the first 2 circles. The first circle, the second instruction creates the second circle. And the last try statement creates only the first circle. So this would create the first and the last object. Any questions? And then the number of objects would be 2. Any questions? We didn't crash the program. The second try-catch block will trigger an exception, which is caught here. We print the exception, and then we continue creating the third object without crashing, without stopping the execution. Any questions? Yes, you can do that with a loop. We actually had a while loop here. Here, a do while loop. My problem here is that if you want to create the 3 circles, then you should create an array of circles, no? So you can create here a circle array. C, which is a new circle array. Of three elements. Then we can use here C of I. We don't need the second and third instructions, so we can put 4 integer I is equal with 0. I is less than 3 in our case, I plus plus, it executes the try statement. Any questions? Yes, please. So it will create two objects, the object at index 0 and the object at index 2. So it will print out that the number of objects is 2. Because only for the one in the middle we catch the exception, and then we continue, after we printed this statement, we will continue to create the third object. Trying to create the third object. Any questions? Yes. So the question is here that this is radius cannot be less than 0 is actually the statement that is printed when we print out the exception. That we print out that that is an exception of illegal argument exception, colon, space, radius, the string that is inside that exception. It strictly is greater than equal with 0. It can be. It doesn't trigger the exception if the radius is greater than 0, strictly greater. This is greater than equal with 0. So it never goes on the else branch if you're giving a positive value. What about negative? It triggers an exception. What if it's 0? Sorry, I cannot hear you now. Do strings have value? But, if I call the method here the circle with a value, with a string, there is no constructor that takes a string as the input. We have a default constructor that takes no arguments and a constructor that takes a double. So you will have a compiler error that you cannot create a circle with exception with that string. Why the constructor? It does. The default constructor calls the constructor for C. You are right. Since the second constructor can throw an exception, the default constructor should also throw the same type of exception. I assume that I didn't put it there because I couldn't fit it in the slide. Now you are right. Any questions? That was it? Yes, and that exception is thrown into the circle. We should also leave it here. That exception is propagated outside. Every single method up in this hierarchy should throw that exception. So this if statement needs only to be in the set radius, because once the exception is thrown, it will also be thrown from the circle with exception constructor. It calls the method set radius, which generates that exception. It calls the method set radius, and that set radius will compare it with radius with 0, and finishes the program. It basically throws the exception if the radius is less than 0. Yes? It does. So that's why I modified the default constructor to also throw that exception, because it calls the constructor that throws the exception. Every method that calls a method that throws a check exception must either throw the exception or enclose it in a try-catch block. So it was my mistake. I changed the slide here. We said that every method that throws an exception must be either enclosed in a try-catch block, or it should rethrow that exception. So you are right. In this program, at least your colleague was right if that was what he asked, this program will generate a compiler error that it doesn't have the throw illegal argument exception in the default constructor. It doesn't automatically throw the exception. It throws the exception only if there is if you throw that if you go on the else branch of this if statement. But if a method M3 throws an exception E, and this method M3 was called in the method M2, and method M2 was called from the method M1, this exception is propagated out until it finds a catch statement for that type of the exception E. So we are rolling back the whole stack, all the methods back until we find a method that has a try-catch block. Okay. Any questions? Okay. The finally clause. The finally clause is used in order to clean up the memory. So for instance, we can try a set of statements, catch the exception. If either in the case that we caught the exception and there was an exception, or we executed the statements without any exception, we must execute the finally block. So it's always executed in either case that the try block throws an exception or not. And is used for cleaning up, like for instance closing streams, like an output stream, if it's different than null. It's used also for garbage collection, to initialize variables with null that should be garbage collected, and so on. Any questions? Yes, please. Yes. So if there was an exception caught in one of the catch blocks, the finally is executed after the handler of the exception is executed. So the finally is always executed, either in the case that there was an exception or if there was no exception. So finally is used usually to close up streams, input streams or output streams. Any questions? Okay. So now the question is when to use exceptions. One thing that you have to remember is that exceptions are expensive. So the general rule, since to handle exceptions you have time and memory consumption. To handle the exception, you basically have to separate the error handling from the normal programming tasks. That means that if you know how the input is correct, and in the current method you know how to handle the input, basically you don't have to throw an exception. If the input is not correct and you know how to handle in the current method the input, even if it's not correct, you should again handle the exception and not throw it further, because you don't want to return exceptions as objects. They are expensive. So exception handling usually requires more time and space, because it requires instantiation of new objects on the stack. The creation of the object is time. The object on the stack now is additional space. You should avoid it. But avoid it only when you know how to handle the exception. If you don't know how to handle the exception, you must throw it. Throw it to the caller. Okay? So exceptions are unusual cases. If you know how to handle them, because it's time consuming to throw them out. If you don't know how to handle them, throw them to the caller. That means that you define that your method throws that type of exception, and your method, now the call for that method, will be put within a try-catch block. So, for instance, if we know that we want to print the string representation of a variable, and the toString method is a dynamic method for a variable, if we know that we can compare the reference variable with null, and only then print the value, otherwise all that we want is actually printing that the reference is a null reference, is an address that is null, then you should better put it in an if statement, if-else statement. Why? Because in the first case, although we are doing exactly the same thing, we are also creating an object of the type null pointer exception. Okay? So try to replace all the try-catch blocks that may generate exceptions with if statements if you can handle the exception in the place where you put the try-catch block. Any questions? Okay. But you cannot always do that. So you cannot, if you cannot do that, put within a try-catch block. Martin's question earlier was how to define your own customary class of exceptions, user-defined exceptions. You have to use one of the classes in the exception classes and define classes which extend the predefined classes. So again, since it's time consuming, you only do that if you couldn't find any predefined classes which may match your type of exception. Like for instance, you want to extend the type of exception with a field or something. In that case, you can just construct a new type of an exception which extends the class exception, extend it with additional fields, like for instance, in this case, the invalid radius exception defines the field radius, and then do constructors for the class, like for instance, the invalid radius exception takes a double as an input and calls the superclass exception constructor to create an invalid radius with a given radius, and initialize the data field radius with a given radius, and then we can use it in a circle with exception example 2, which in the set method, when you set the radius to a negative radius, it throws an invalid radius exception. And again, that will be thrown by the set radius exception, and it can be caught in the circle with radius exception. So in this case, I chose to modify the constructor for circle with radius exception to try to set the radius and increment the objects, otherwise catch the invalid radius exception. So another way to fix our method, our main method for creating 3 circles with the second circle with a negative radius, would be to put the try-catch block within the constructor. And then we are actually not going to construct a second circle. Any questions? Okay. So now let's do the quiz. And the quiz will also be part of the lab for today. The first problem of the lab is actually asking to implement a calculator with 3 arguments. The first argument, when you try to run your program with Java calculator, would be the first operand, then the operator, then the operand. So what we do is basically we want to call Java with the class calculator with 3 arguments, 1 plus 2. So now the main method of the class calculator has as an input an array of strings, string array args. This is the input, this is basically the input for this method. It basically takes 1 plus and 2 as strings and puts them into an array with 3 arguments. So What I'm doing here, I basically check if the length of that array is different than 3, then I just inform the user that he did not use the calculator class properly. He should use it by giving the operand 1 operator and operand 2, and then I exit the program. Now, since what he entered as the three strings may not be integers, maybe, for instance, the letter A, we have to handle the exceptions that are triggered by the parseInt method. So integer.parseInt may throw a number format exception if the string argument is not an int. So in this case, it throws that if the string is not an integer. In that case, we have to print that is the wrong input, and we print the value of that argument. I will enclose in try-catch blocks every one of these conversions from string to number. So number 1 is equal with integer.parseInt of argument of 0. Number 2 is integer.parseInt of argument of 2. The first and the third argument of args, this one and this one. And then in a switch statement, switching on the character of the second argument of the program. If that character is plus, I do the summation. If that character is minus, I do the difference. If that character is multiplication, I do the multiplication. Otherwise, if that character, if is the division, I do the division. And again, I use a try-catch block, because the division with a 0 can generate the division by 0 exception, which is a subclass of exception. So in the catch block for the division, I print out that the division is equal with 0. At the end of the switch case statement, I just print the value of the result. Any questions? Yes, please. You can. No.
It throws an error when you try to use it.
Unfortunately, I don't have Java on the things on this computer. But did you try to put it like 1 star 2 within like a string? Run configuration, and you have also to separate them with spaces. They are spaces, okay. So put the star within double quotes. Double quote before and after, and run it. And 2 is an invalid input. Debug it line by line. So the same program, click on debug and see where it stops and why that is the case. Because it catches an exception when you're trying to parse the second argument too. It doesn't catch the exception at the end. So debug it line by line, click on the bug. You have to put a breakpoint before you start debugging, like at the beginning of the program. Okay. Now execute it line by line.
That's fine. I'll take a look at it sometime.
Here. Unfortunately, it's here. So let's see what is in your variable. So J, you generated an error when you try to parse the integer, the second argument. So let's go back to your program. Where is the run? This is the program that you're running? Calculator. Run S, run configuration. You have 1 space point. It's correct. Star, it doesn't work. It doesn't, because it's one of the arguments of our program. So I will try to debug it and get back to you. Any questions? Yes, please. They are initialized when you actually try to parse the integer that is in the argument. That means that you probably don't exit, because if you don't initialize them with these two assignment statements, then you will get an error here that one of them is not initialized. But if you exit once you get an exception, you shouldn't get that numbers are not initialized. So I can take a look while your colleagues are still writing the program.
I mean, I just initialize it up here.
So run.
Oh no. I guess the error just went away. I was saying these two are initialized.
Okay. It went away. Any questions? Yes.
What's the difference between system.exit 0 and 1?
System.exit exits the current program. If you give a positive value, that means that it exits with the program ran correctly, and that's what is returned in C. When you try to run a program, you get an integer representation of how the program ran. 0 means that the program exits, but with some error. I exit with 0 because it's I got an exception. That's why I exit. Okay. So it's inherited from Linux, the fact that everything in Linux ends with an integer, executes with an integer. Now the second problem, did you finish the first program? If you didn't finish, please raise your hand. Okay, please finish the program. Yes, please. Oh, scroll up, scroll down. This is the end of the program. Scroll up. So just the only thing that I do in the end, I print out the result. So if everything went correctly, executing Java calculator 1 plus 2 should return 3. Yes, please, Wendy. It's predefined. It's one of the subclasses of the exception class. What you can do is always remember exception class, because there are many types of exceptions, but the exception is the superclass of all of them. So then, in all of these cases, you can just say catch exception EX. Catch exception EX. You can see that actually I did that for number 2. Catch exception EX when I have the division by 0 exception. So the number format exception is just a subclass of that exception class. Yes, please. That error came back. So first thing that I would do, I would reformat this. Okay, so now I can see the program a little bit better. You define the two variables. Shouldn't have that error.
I mean, the error went away after I initialized them to 0.
I know, but they shouldn't be, because you are initializing them here. So the only possible case that you get there is you don't exit. So initialize them, because it looks like it doesn't, Eclipse, this version of Eclipse doesn't realize that there is no way to get there without initializing them. Initialize them. So the problem there is that it should realize that since in all the possible exceptional cases you exit, that means that there is no possible way to get to that line, the summation, without having them initialized. Any questions? Yes, please. To parse it. So it's the same thing, because the type of the exception is of the type number format exception. But that is a subclass of exception class that I will catch in the case of number 2. So it's the same thing. It's basically every number format exception, it's also an exception. Okay? So they are basically the same. You can write in all the cases, catch exception, and done. Catch exception will catch any exception.
So like if you put a more specific exception,
it will catch only that type of exception, only number format exception. Okay. So I hope that everybody is done with the first problem. Let's do the second problem. So the second problem requires that we implement our own user-defined class hex format exception, which just have a constructor, has a constructor in this case. I want to remember that there was an exception of that class. So I can write this class, hex format exception, that extends the exception class and just has the constructor. Then in the hex format exception quiz, I have the main method, which tries to parse the hexadecimal number A5. The parse method for that hexadecimal number takes a string as the input and may return an integer of representation of that hexadecimal number, or if one of the characters of that string is not a hexadecimal digit, is not between A and F or 0 and 9, it throws a hex format exception. So now I start with the value is equal with the convert hex to decimal, one character, the character at index 0. In a for loop, I increment the value of I from index 1 up to the length of the hexadecimal array, and the value is equal with the value multiplied with 16 plus the character at index I minus 0. Actually, sorry for that, I hope you don't get there yet, because I have to call the same method. So it actually converts hexadecimal to decimal and then of the character at index I. So now my last method, convert hexadecimal to decimal, will check if the character was between A and F, and then returns character minus A, uppercase A plus 10. If the character is between A and F in lowercase, it returns character minus the character for A plus 10, because A corresponds to 10. So since we are having a string for A, subtracting the string for A returns 0, and adding 10 to that, we return the hex the integer for the hex representation for A. Now for F, we will actually return 15. So my convert hex to decimal takes a character and returns the integer representation of that character if it's one of the hexadecimal types characters. Or if it's not a hexadecimal character, I throw the hex format exception. So that is thrown from the method convert hex to dec, is thrown from the method parse hex, and is caught in the main method. The main method, when it tries to parse the hexadecimal number that may contain other characters, it can throw and catch the exception and print it. Any questions? Yes, please. Yes. So the only thing that I did in the exception class, I said that the class hex format exception extends exception, and I implemented a constructor for that class. So from the method convert hex to dec that converts one character to hexadecimal, I throw the exception to parse hex, and then I throw the exception to the main method which catches that exception. So these are two of the problems that you have today in the lab. Okay. One of the problems in the homework is to do the same for binary numbers, a binary number format exception, and then parse a binary string into an integer and generate a binary number exception in the case that one of the digits of that binary number is not 0 or 1. Okay. Yes, John.
Just on the homework. The result should be a decimal, right?
Yes. Yes, please.
So what's the hex to decimal doing? It's returning the character.
Returns the integer representation of that character. So if the character was 0, it returns 0. If the character is up to 9, it returns 9. If the character is A, it returns 10. If the character is B, it returns 11.
So A is worth 10 in this case?
That's what we did in hexadecimal, 0 to 9 and A to F. So while you're writing that program, let's try to do together the exercise from the homework that requires you to trigger an exception for a binary parsing. So again, you have to define a class binary exception that extends the exception class. You have to have a constructor for that class, so let's write the binary exception constructor that takes a string and then calls the superclass constructor with that string. And that's my entire exception class. Then I can define my main method, public class parse binary, which has a parse method. So we have a public method static that returns an integer. We can call it parse, takes a string, which is the binary string, as an input. Once everybody is done with the quiz, you can see what I'm writing there. It throws a binary exception object. So now again we do the same thing that we did here in this conversion. We define an integer value, which by default is equal with 0, and then in a for loop for every character starting from index 0 to the length of our string, I have two possibilities. If the character, let's actually define a character, which is at the position, character at position I. If the character C is different than the character for 0, and the character for C is different than the character for 1, then I can just throw a new binary exception for the given with the given character, like for instance, not a correct bit, and the value of the character C. I will, but first I want to make sure that everybody finished the quiz. So now here I can say the value is equal with the old value, multiply with 2, plus the value of the character C minus the character for 0, because 0 represents the character 0. That finishes the for loop, and I return the value. Now in the main method, did everyone finish with the quiz? Yes, okay. Inside the try-catch block, I try parsing a string that may contain 0 and 1, and let's say also 2, 4. That will generate an exception, and we can catch that exception. and we can print the exception. That's all. Any questions? Okay. That's all for today. Please bring me the quizzes. See you next class. Done.